Hi dears, this is Raji. We are learning how to express the concentration of a solution. In the previous video, we were discussing about the percentage as well as the strength of a solution. If you haven't watched that video, please click on this link and just go through that, okay? So that you can learn the concept from the very beginning. In this video, we are going to discuss about the molarity, the most important term to express the concentration of a solution. Okay, so watch the video till the end and we will be doing number of problems related to that so that the concept will become so easy for you. So let's start with it. See this one. What is molarity of a solution? It is nothing but a term to express the concentration of a solution. So you'll be thinking, in the previous video we were expressing the concentration in terms of strength and percentage. Now we are speaking about molarity. It's our convenience. Depending upon the experiment we perform, we will be using different terms of concentration. That's all. Okay. So molarity is defined as the number of moles of the solute dissolved in 1 liter of a solution. What is the meaning of that? To understand that better, we are going to prepare 1 molar sodium hydroxide solution. Okay? Yeah. For that, you need to weigh exactly 1 mole of sodium hydroxide. You will have to dissolve the same amount in 1 liter of water. Correct, no? Yes. Now tell me, what will be the mass of 1 mole of sodium hydroxide? How to calculate the molar mass of a substance? We have already discussed about it. Okay. The molar mass of sodium hydroxide will be 40 gram. How you are getting it? Molar mass of sodium will be 23 gram. Oxygen 16 and that of hydrogen will be 1. If you are adding everything together, you will be getting 40 gram. So, you are weighing exactly 40 gram of sodium hydroxide. We are dissolving the sodium hydroxide in little amount of water and transferring that into a round bottom flask. After that, we are adding enough amount of water and making the volume up to 1 liter. Correct? Now, 1 mole of sodium hydroxide is present in 1 liter of water. Correct, no? Yeah. If so, what will be the concentration of this solution? This solution is 1 molar sodium hydroxide, we will say. Got it? Now, I would like to prepare 2 molar sodium hydroxide solution. What I will do? I can take 2 moles of sodium hydroxide and I can dissolve in 1 liter water. So, the concentration of the solution will be 2 molar, we will say. Right? Now, I would like to prepare 3 molar solution. What you will do? 3 moles of sodium hydroxide we will be dissolving in 1 liter water. That time, the concentration of the solution will be 3 molar. Now, think about it. I don't have a 1 liter flask. Instead of that, I have a 250 ml flask. So, that time, how to express the molarity? The problem is there in the next page. Okay, we will do that. Now, read the problem. Calculate the molarity of sodium hydroxide solution prepared by dissolving 4 gram of it in enough water to make 250 ml of the solution. Here they have made the volume only up to 250 ml, not 1 liter. So how to do the problem? First of all, write what is molarity. To calculate molarity, we need number of moles of the solute first. But they didn't give that. Okay. Instead of that, they have given mass of sodium hydroxide solution. So, how to calculate the number of moles? Related to mole concept, we learned about that also. What is a shortcut formula to calculate the number of moles? That will be equal to given mass divided by molar mass. What will be the given mass? That is 4 gram. Correct? And what will be the molar mass of sodium hydroxide? We have calculated just now. That will be equal to 40 gram. So, the number of moles will be equal to 1 by 10 or 0.1 mole. We got the number of moles of the solute already. That is 0.1. Okay, divided by what will be the volume of the solution? That should be in liter. Here they have given in milliliter. So 250 ml has to be divided by 1000, or we can multiply it by 1000. Correct, no? If you are calculating this one, you will be getting the answer as 0.4 molar. Remember, when you are writing the unit of molarity, you will have to write capital M. So the answer is 0.4 molar. Now let's do one more problem. How many grams of sodium hydroxide should be dissolved to make 100 centimeter cube of 0.15 molar sodium hydroxide solution? Here molarity is given and the volume of the solution is already given. We will have to calculate the number of moles of the solute. From that you can calculate the mass of the substance also. Correct? Yeah. So write it. How to calculate the number of moles? We will write this one as N and we will write this volume as V. Now find out the number of moles. Number of moles will be equal to molarity, capital M we will write into V. Correct? What will be the molarity of the solution given? That will be equal to 0.15 molar into volume should be in liter. 100 centimeter cube. How can you convert it into liter? We will divide it by 1000. Correct, no? So that much liter. So substitute that also, 100 divided by 1000, right? Yeah, so it will be equal to 1 by 10. Number of moles will be equal to 0.015. But they are not asking the number of moles. Instead of that, what will be the mass of 0.015 mole of sodium hydroxide they are asking. We have a shortcut formula. Write that number of moles is equal to given mass divided by molar mass. Correct? What will be the mass of sodium hydroxide taken? That will be equal to number of moles. That is 0.015 into what will be the molar mass of sodium hydroxide? That will be equal to 40 gram per mole. Correct? So that also we can substitute in this. You will be getting the mass of sodium hydroxide as 0.6 gram. Okay, so this will be the answer. Easy, right? Now you might have got an idea how to calculate the molarity of a solution. But for your exam, mainly you will be getting 3 types of problems related to molarity. They will ask you what will happen to the molarity of a solution upon dilution. Yeah, if you are mixing 2 solutions, what will be the molarity of the new solution? Okay, and again you will be getting questions related to neutralization reaction also. That means when an acid and a base is mixing together, what will be the molarity of the resultant solution? We will be doing problems related to each and every concept so that you will become perfect with all that. See this one. This is a dilution problem. Before doing the problem, you should have a clear idea about what will happen to the molarity of a solution upon dilution. See, this picture will make the idea clear. Okay. In the first solution, I have taken 5 moles of the substance in 1 liter water. Okay, so what will be the molarity of the solution? It will be 5 molar only. Okay. After that, I am adding some amount of water into that. 1 more liter of water I am adding. Yeah. Can you observe the picture and tell me, is there any change in number of moles of the substance? No, because we are adding only some amount of extra water. The number of moles of the solute before dilution and after dilution will remain the same. Now again write it. What will be the molarity of the new solution after dilution? 5 moles are now present in 2 liter water because I have added 1 more liter of water to the existing one. Okay. Now what happened to the molarity of the solution? That will be equal to 2.5 molar. Correct? Yeah. The molarity of the solution is decreasing. Using the same concept in mind, we are going to derive a shortcut formula to do dilution problems easily. How to do that? Can you tell me what will be the molarity of the solution? You write it. Let it be M1. Number of moles present in this solution be N1 divided by V1 will be the volume of the solution in liter. Agreed? And what about M2? M2 will be equal to, see, upon dilution, there is no change in number of moles we are telling. Number of moles will remain the same only, right? So, the number of moles present in the second solution will be N1. Okay, we are not changing that because it will remain the same. Divided by volume will be changing. Let it be V2. If so, we can also write it as N1 is equal to M1 into V1. Here number of moles will be equal to M2 into V2. Correct, no? Yeah, number of moles should remain the same. If so, we can also write this expression as M1V1 is equal to M2V2. Clear? Yeah. This is a shortcut method to solve dilution problems easily. Okay. So, using the same equation, we are going to solve this problem also. Let's write that. Read the problem. Calculate the molarity of a solution prepared by diluting 25 ml 0.05 molar potassium iodide with 50 ml water. So initially you have 25 ml of 0.05 molar solution. So what will be the value of V1? V1 will be equal to 25 ml. Agreed. What about the molarity of that solution? M1. M1 will be equal to 0.05 molar. Okay. Now you are adding 50 ml of water into this. Okay. What will be the value of V2? Some people will jump upon and write the value as 50 ml. Wrong. Why? Because already we have 25 ml. To that you are adding 50 ml. So what will be the total final volume? That will be 50 plus 25. That will be equal to 75 ml. Clear? Okay. And what will be the molarity of this new diluted solution they are asking. So you will have to calculate M2. So for dilution problem, we can use the shortcut formula V1M1 is equal to V2M2. From this, you can calculate M2. M2 will be equal to V1 into M1 divided by V2. Substitute the value. 25 into 0.05 divided by 75. Okay. If you are calculating this one, you will be getting the answer as 0.016 molar. Okay, that will be the molarity of the new solution after dilution. Easy? Yes. Now try another one. What volume of water must be added to 100 ml of 0.02 molar sulfuric acid solution so that its molarity becomes 0.002 molar? This is also a dilution problem. So write it. What will be the initial volume given? V1 will be equal to 100 ml. Correct. What about the molarity of that solution? That will be equal to 0.02 molar. Now, what is the required molarity of the final solution? M2. M2 should be equal to 0.002 molar. From this, we can calculate V2. For dilution problem, what is the formula we use? V1M1 will be equal to V2M2. Okay, from that V2 will be equal to V1 into M1 divided by M2. So substitute the value. V1 is equal to 100 into molarity will be equal to 0.02 divided by, what is the value of M2? That will be 0.002 molar. If you are calculating the value, you will be getting the answer as 1000 ml. V2 will be equal to 1000 ml. Now think about it. Is this your final answer? No. Why? Because initially you were having 100 ml of the solution. The value of V2 you are getting, that is 1000 ml, is the total final volume after adding some amount of water into that. Already 100 ml water is present. Now 1000 ml. So how much amount of water you might have added to that? The answer is 1000 minus 100, that is 900 ml. Okay? Yes. If it is coming as a multiple choice question, they will be giving 1000 ml as the first answer. Okay. So you should think about and answer it. Okay. The correct answer is 900 ml. That means 900 ml of water you will have to add to the initial solution to make the molarity 0.002 molar. Easy? Yes. Now see this question. 400 ml of 1 molar H2SO4 is mixed with 600 ml of 2 molar H2SO4 solution. Calculate the molarity of the resulting solution. So this is the second type of problem you may get related to molarity. That is, we are mixing two solutions and they will ask you what will be the molarity of the resulting solution. From this picture itself, the idea will be clear. In the first solution, suppose 5 moles are present in 1 liter water. In the second case also, 5 moles are present in 1 liter water. We are mixing both the solution. As a result, what is happening? See, the total number of moles now present in this solution will be 10 moles. Agreed? 10 moles are present in how much amount of the solution? That is in 2 liter solution. So whenever you are getting this kind of mixing problem, how to calculate molarity, you will have to find out the total number of moles divided by total volume. In this kind of mixing problem, there is an easy and a shortcut formula. How to calculate that? You write the molarity of the first solution. Let it be M1. That will be equal to N1 divided by V1. Agreed? Yeah. N1 moles are present in V1 liter. Okay. What about the molarity of the next solution? You write it as M2. Number of moles present in that will be N2. That is present in V2. So what will be the number of moles present in both these cases? You write it. N1 is equal to M1 into V1. N2 will be equal to M2 into V2. What we were telling, in the case of mixing problems like this, what will be the final molarity of the solution? Total number of moles divided by total volume. That means N1 plus N2 divided by V1 plus V2. What is N1 in this case? That will be equal to M1 into V1 plus M2 into V2. That will give you N2 divided by V1 plus V2. Understood? So this will be the new molarity of the resulting solution. So whenever mixing problems are coming, you can use this shortcut formula. M1 into V1 plus M2 into V2 divided by V1 plus V2. Using the same shortcut, we can solve this problem also easily. Let's do that. See, 400 ml 1 molar H2SO4 solution. So let it be V1. V1 is equal to 400 ml. And molarity will be M1. That will be equal to 1 molar. Okay. That is mixed with 600 ml 2 molar H2SO4 solution. So V2 will be equal to 600 ml. What will be M2? M2 will be equal to 2 molar. Right? Yeah. Calculate the molarity of the resulting solution. So do that. Yeah. V1 into M1 plus V2 into M2 divided by V1 plus V2. This will give you the new molarity. Yeah. While doing this problem, some children will be having a tendency to convert this volume into liter. That will make your calculation highly difficult. In this case, it is not required. Why is it so? Because the volume is coming in the numerator also and denominator also. So in order to make the calculation simple, don't convert it into liter. Keep it in ml itself. You will be getting the same answer. Substitute the value. If you are calculating this one, you will be getting 1600 divided by 1000. See, now calculations are easy. So don't convert it into liter. You will be getting the answer as 1.6 molar. That will be the molarity of the resulting solution after mixing. Easy? Yes. Now read this question. Two solutions of substance non-electrolytes are mixed in the following manner. 480 ml of 1.5 molar first solution and 520 ml of 1.2 molar second solution. What is the molarity of the final mixture? So this is another example for mixing problem. For that kind of problem, what's the shortcut? V1 into M1 plus V2 into M2 divided by V1 plus V2. This will give you molarity of the resulting solution. So what will be the volume of the first solution? That is 480 ml into what will be the molarity? That will be 1.5 plus what will be the volume of the second solution? That is 520 ml. 520 into 1.2 molar. Okay. Divided by total volume. 480 ml plus 520 ml. Together if you are adding, you will be getting 1000 ml. If you are calculating this one, you will be getting 1344 divided by 1000. Easily you got the answer. Okay, so what will be the answer? 1.344 molar. Okay, in this case the answer is B. Is it easy for you now? Yes. Now see this question. Calculate the molarity of the solution obtained on mixing 100 ml 0.1 molar hydrochloric acid with 50 ml 0.1 molar sodium hydroxide solution. This is the last type of problem in which an acid and a base will be mixed together, and they will ask you what will be the molarity of the resulting solution after neutralization. We know that acid and a base are mixed together, it will react with each other. Whenever you are getting this kind of problem, you will have to write a balanced chemical equation first. First you write that hydrochloric acid will be reacting with sodium hydroxide. What will be the product obtained? You will be getting sodium chloride and water. See, we don't want to balance this equation. It is self-balanced. Okay. Now, after that, you find out how many number of moles will be present in this acid. Okay. So, separately, we are going to find out the number of moles of the acid and the base before mixing. Okay. Yeah, find out. So, in the case of acid, that is dilute hydrochloric acid. Yeah. What will be the volume given? Volume given V will be equal to, or V1 you write 100 ml. What will be the molarity of the acid solution? M1 will be equal to 0.1 molar. From this, is it possible to calculate the number of moles? Yes. Number of moles N1 is equal to V1 into M1. Yeah, you substituted 100 ml into 0.1 molar. See, in this kind of problem, I suggest that don't convert this volume into liter. Okay, because if you are converting the volume into liter, you will end up in decimals. That will make your calculations difficult. So, how can you write it? Don't convert into liter. Instead of that, 100 into 0.1, that will be 10. Millimoles we will write. Agreed? Okay, we didn't write anything wrong. Instead of moles, as we are not converting volume into liter, we are writing it as 10 millimoles. So, this is the number of moles present in the acid before mixing. In the same way, we are going to calculate the number of moles of this base before mixing. Find out what will be the volume of the base taken. V1 is equal to 50 ml. What will be the molarity of that? Let it be M1. That will be equal to 0.1 molar. Now, what will be the value of N1? V1 into M1. 50 ml into 0.1 molar. We are not converting into liter. Instead of that, we are writing it as 5 millimoles. Okay. Now again look at the balanced chemical equation. As per the balanced chemical equation, 1 mole of acid can completely neutralize 1 mole of a base, because that is in 1:1 ratio. Okay. Now see this one. You have taken 10 millimoles of acid and 5 millimoles of base. Will it neutralize completely? No. 5 millimoles of base can completely neutralize 5 millimoles of acid only. Understood? Then what will happen to the rest of 5 millimoles of acid? That will be present inside the solution even after neutralization also. Understood? Out of this 10 millimoles, 5 millimoles will be neutralized by the base. So, the resulting solution will be acidic in nature. Correct? No? It will be containing 5 millimoles of the acid. Now, they are telling you to calculate the molarity of this resulting solution. Okay. Now, write it. Molarity of the resulting solution will be equal to 5 millimoles divided by what will be the total volume of the solution after mixing? 100 ml plus 50 ml. So, that will be equal to 150 milliliter we are writing. Okay. So, this milli will be cancelled and you will be getting the answer as 1 divided by 30. Yeah, moles per liter. Moles per liter is nothing but the unit of molarity. Capital M you can write. Or the answer will be equal to 0.033 molar. This will be the answer. Got it? Yes. Already our video has become so lengthy. So what to do? We will be doing one more problem. You read this one. Calculate the molarity of the solution obtained on mixing 100 ml of 0.1 molar sulfuric acid with 50 ml of 0.1 molar sodium hydroxide. This is also similar to that of the previous problem, but there will be a slight difference. Okay, yeah. So you write the balanced chemical equation first. Sodium hydroxide will be reacting with sulfuric acid, yeah, resulting in the formation of salt and water. Sodium sulfate and water will be produced. Okay, you will have to balance this equation first. Okay, so we will put a 2 in front of this one and we will put a 2 in front of water also. Now what we need to do? We will have to find out the number of moles present in acid also, base also separately. Okay, so you write it. What will be the number of moles present in sulfuric acid? Volume of sulfuric acid V1 will be equal to 100 ml. Okay, what will be the molarity of that? M1 will be equal to 0.1 molar. So from this, is it possible to calculate the number of moles? N1 is equal to V1 into M1. That one will be equal to 10 millimoles. We are not converting it into liter, so that you can do the problem easily without decimals. Okay. Now in the same way we will be writing the number of moles of base also. What will be the volume taken? V1 is equal to 50 ml. And what about the molarity of the solution? M1 will be equal to 0.1 molar. If you are calculating the number of moles in this solution, it will be 5 millimoles, right? Yeah. V1 into M1, that will be equal to 5 millimoles, right? But here acid and a base is not reacting in the ratio 1:1. 2 moles of a base require only 1 mole of an acid for complete neutralization. That means if you take 10 moles of a base, that needs only 5 moles of acid. Here we have 5 millimoles of base. That needs only 2.5 millimoles of acid for complete neutralization. Did you get it? But you have taken excess amount of acid, that is 10 millimoles are present in the solution. Out of this one, 2.5 millimoles will be completely neutralized by this base, right? So the remaining solution will be acidic in nature. Find out what will be the remaining amount of acid after neutralization. 10 minus 2.5, that will be equal to 7.5 millimoles. This will be the number of moles of the acid present in the resulting solution. They are asking you to calculate the molarity of that solution. So now write it. Molarity of the solution will be equal to, what will be the number of moles of the acid present? 7.5 millimoles divided by what will be the total volume in milliliter? 50 ml plus 100 ml, that will be equal to 150 milliliter. So this milli will be cancelled and you will be getting the answer as moles per liter. That is a unit of molarity only, right? Yeah, capital M you can write. So the answer will be 0.05 molar. This will be the molarity of the resulting solution after neutralization. See, while doing the problem, we didn't convert the volume into liter, but easily we got the answer. To explain the entire concept of molarity, it took half an hour. Hope you might have understood the concept so well. See you in the next video. Till then, bye for this time. Thanks for watching.